Now I'm going to take you through the fluid solver and the input, behavior and appearance of this fluid. So this solver is basically a simple fluid simulation. We have three main panels here. We've got, for that, the output we'll talk about together with the other combustion solver. So the input is basically the input to our simulation. So here, in this case, we are using a system as an input. So you can see you've got this very simple little particle system, and that is actually what's driving it. We can actually change, for example, if I was to sort of turn this off, you see that it just starts to fade out, so we're going to turn it back on. The color of this is actually currently being used for the intensity of it, but we can change it right here by just reducing the strength of the input. Or, if you put it back to 0, it's basically like turning it off, or you can kind of whack it up. It actually can go above this value if you want to. So that's the driving input, and over here is where we actually set it. What's very important is that in order for this to be saved as part of this preset, you will need to make sure, if I make any changes to this, for example, let's make a change. I'm going to move it up, make it more particles, change it to a sphere, make it bigger maybe. So we've got like a different driving thing. So what I want to do is I'm going to change and give this a different new name, maybe input sphere. And I'm just going to, you can put it anywhere. I'm just going to drag it into this inputs folder. You'll see, and then I'm going to drag that back into here. Don't worry about it going white, because what we're going to do is we're going to save it to and we're going to overwrite the prefab, and then you see it's actually going to reset. So now we have that as a particle system. Now this is very strong, so I probably want to like reduce the input strength. And maybe, yeah, so that's like, we'll change the behavior in a moment. So let's just save this and just overwrite it. So the next thing that I want to show you about the input is we have an input texture. So if we don't want to use a particle system or anything in the actual physical space, so this particle system is being rendered by this input camera, and that's actually the input texture. But we can actually just have a single texture that could be our input. So let's say, just look for, I think there's a fluid texture somewhere. Here we go. Could use this. Let's reduce the fluid, the strength. You can see it's like basically driven by the actual texture, and it's the brightness of that texture. So one will be much more strong, and like black will be basically not inputting anything. So that's the input texture. You can see it's completely ignoring this prefab now that it's got that texture. But let's turn it off and just use this one again. So now I'm going to show you about the input mouse. So you can actually just like draw with your right click. You can add sort of fuel to the to the simulation, or you can, with left click, you can drag and kind of form it. And you've got the exponent, which is how so the smaller the exponent, the bigger that's going to be, and the bigger it is, the smaller that will be. And then you've got the strength, which is the strength of the fuel, so less, smaller will be just more soft and less fuel coming in. And then the force is obviously how strong you are with your left click to push it around. And this is all like something you can do as you're recording. You can kind of just make a few changes. But it's also like this is a feature that's much more important when it comes to the live, but that's something for later date. So that's the input. Now I'm going to talk through the behavior. So right now, we haven't really done much with the behavior. It's kind of taking a long time to fade out, so maybe we want to like sort of if we increase the fade rate, it's going to fade quicker, so it might so it can sort of fade out a little bit earlier, or if we can put it down, then it takes a lot longer to fade out. So let's increase the fade out and increase the input a bit. And then we have iterations. Now the iterations is basically the quality of our simulation. The higher it is, the actually more expensive it will be as a shader. But it's really just, you'll get more accuracy if you do upfits, so it'll kind of flow a lot better. Obviously, just be mindful based on how good your graphics card is, how high you want to be putting this up. Viscosity is something we'll be using for any time we're doing a more liquidy sort of effects. So a 0 viscosity will basically act more like smoke or fire, whereas if you put it up, then it becomes more like liquid. It's a bit more expensive to have viscosity, so I tend to keep it off if I'm doing kind of smoke effects or fire effects. So one of the biggest drivers for your simulation will be your wind and your turbulence. So that's on the wind and turbulence section. You have a vector. The Z isn't important in this case. It'll be for the live, but not for this. So you can see it's 1 there. If I make it -1, it'll start like flowing down. You can change this to make it a larger number, or just do it like left and right. But it's a good idea just to use the wind strength, and then that you can tweak it sort of with a set direction. The turbulence strength is using this turbulence texture to distort it. So at the moment it's using kind of quite a noisy one. I've got a fluid, it's called, actually I remember the name of it, I think it's called, it's a flow map. So this is basically a fell swirl, that's right. So you've got a swirl, this is like a swirly, it uses the RNG as a flow map, and so it's quite very, very strong, so I'm going to just reduce this down. But you can, and the scale of that texture is driven from this, so if I up it, you can start seeing like little swirls and everything like that. Then, so if I reduce it now, it's like, you can see it's actually changing, it's making bigger swirls. So you can make a lot of differences in the way that like the simulation runs just from this alone. I'm going to reduce the strength of the wind, so it's more, so we can see more of the flow. And so now the next, so I think I'd tell you about the flow map is you need to make sure that the flow map, the sRGB is not on, because that way 50% will be like not moving it, and so values less than 50% will be moving it to the left and right, and above 50% will move it to the right, and that's in the R channel, and the G will be the same, will be up and down. So that's the behavior. So let's go to the next thing I'm going to do is the appearance. So as you can see, we've been looking at this blue thing for a while. It's all because of this remapped gradient we've got here. So we can like change the color of this by just sort of choosing different colors. Change it here. And basically what it's doing is it's changing the intensity. It's using the intensity and remapping it to a gradient. So we also had another option, which was to use the input color. So in that case, we're actually just using the particle system that we originally had. So if we were to sort of, let's choose a random color and do that, it's actually going to be picking just like random colors and using those colors as the driver of our simulation. But I don't really like the results from gradient, but you can get a lot of different things from doing through the color method. Also, there's the remap density. So you can see here, this is actually not changed. This should not be confused with input strength. Input strength actually changes how strong the simulation is. So you see, if I'm increasing the input strength, it's going to be much more violent, and it's going to have much more of an impact. But if I change the remap density, it's the same simulation. It's just remapping the gradients of these values differently to this. So if you want a softer one, you increase it. If you want it to be much more strong and burny and everything, you can do it that way.